Good evening to all. In this video, we are continue our EDA Tool Tutorial Series Part 5. In this, we are going to see the RTL compiler from the Cadence. Sometimes it's called the Cadence Encounter. We begin first with the presentation. See the details of the commands for the reading the files, constant files as well as source files. Then how we provide the library files and how we can write the TCL file for the RC compiler. So the RC compiler is nothing but RTL code to netlist get netlist generator, and it also provide the information regarding area, power, timing reports as well. So we begin with the presentation. That at the last we see how we can practically provide this or all these files to this RC compiler to generate the reports as well as the schematic. And please subscribe my channel. As so we start with this EDA Tool Tutorial Series Part 5 RC compiler. It's mostly synthesis related and the optimization flow for this TCL file commands and the SDC file generation or creation of the SDC and TCL files. So RC compiler, as I told you, it is from the Cadence, and it converts the RTL code, either Verilog or VHDL, into optimize get netlist. So basically, when in earlier days, as we optimize our Boolean equations using the K-map, it is a similar kind of thing, but it is for the both, like combinational design as well as the sequential designs. Or this compiler also provide information regarding the area, power and timing analysis. So we can correlate this RC compiler with the Synopsys Design Vision compiler, okay, because both these two are doing the same thing. So the requirement for this RC compiler, as we know, we need source files, then constant files. In constant file, basically what is the clock, what is the input output, and what are the input output delays, like that. These things we are placed in this SDC file. And also we need the library from which we have to take the instances of the gates to fabricate the or to have the transformation of this RTL into library dependent get netlist, like that. And what are the commands I am using here? It is relevant to this 9.1. You can refer your user guide under the doc folder. What are the commands they are supporting? Okay. For the library, it is very simple. Set attribute is a command. We have to provide the lib search path, the path of the library, and then we have to set the attribute library. In a curly bracket, we have to mention the name of the library dot lib. SDL files, then search path of library. Then we have to perform the elaboration, apply the constants. First iteration, it's okay. Then for the optimization, we have to go for the efforts, low, high, like that. Under that, it will optimize the resources. Okay. It will synthesize the things after the analysis of the reports, like area, power, timing. If the constants are met, it's okay. If not, we have to modify either the source level or constant level, or we have to modify the constant properly to meet our requirements. So at last, if everything is okay, we use this get netlist and SDC file for the process of the layout and the placement and routing purpose. Okay. So to read the files, there are two versions, like Verilog or VHDL. The command is simple: read SDL. To make the top level module as a current design, you have to use the set my top level name of the module. Then these are some static things. We command like elaborate dollar my top level, which is going to be our name of the file. For synthesis process, there are some options we have, like ungroup all flatten, then ungroup dash simple, or preserve hierarchy. Okay, these are the three options we can have. Then for the synthesis, we can like have the options like effort low, high to generic. Effort low is nothing but fast, for the fast mapping, lower optimization. But if you go for the high effort, it will optimize the design, but it will take some time. Okay, depending on the requirement, you can use this kind of flags. And at last, we need to generate some reports. Reports means first is our get netlist, second is a SDC file. So the command is very simple: write a map, then name of the top level, and we have to assign some path for the file location, like that. Write SDC, then the location of the file. There is a two more report generation: report power, then report timing. We have to provide the depth and the hierarchy depth, like number of the worst paths, like that. So in the SDC file, it is similar to our design vision SDC file. We have to provide the current design name, then clock generation along with the name and the period waveforms, like that. To read the constraint, there is a command read SDC, the name of the your constraint file. So to run the RC compiler with your script from the terminal, you can use the RC-F, your script name, or you can use the GUI, RC-GUI, and under that you can go to the file and provide the source of your tickle. And after that, it will take some time and generate the logs and the reports that we already seen. After analyzing if it is okay, then we can go for the further process of the layout and the placement and route. Otherwise, we have to need to modify the constraint or source file. So these are the 4 reports, like power, area, timing. Then at next stage is our physical design, that is layout design and placement and route, based on the get netlist and the SDC file. And there are some other things we have to provide during the layout process. We will see in. So we are taking some small single code. Okay, it has clock, reset, R or ports, output ports. I am using the active HDL for the generation of this code. I just designed this drag and drop straight machine from the generation option in this active HDL. I generate the code. Okay, this is VHDL code, but you can generate the Verilog code as well. So again, we can able to simulate this code, generated code, and after the generation of this VHDL by default, I just so again it will give the same result. We will see this active HDL in later EDA tool series. Under the RTL, I place all the required atoms. In this code, actually, we are trying to emulate the traffic light signal. We have clock, reset, R, Y, G. Okay, one by one, the R, G, Y signals get logical ones as seen from this waveform. For the completion, I just put the screenshot of the code here. Okay, you can pause, you can write, or you can use your own source code for the process. Please subscribe my channel. So please subscribe my channel and support me. Make comment for the improvement, and please hit like button. So under the RTL folder, there are what we have: one code folder where the source file is there, one constant file, then one tickle file. One by one we see all these things. Vim code, then FSM test1, This is the same file that we saw in presentation. Okay, then constant file, so it is the same constant file that we saw in presentation. Then the TCL file. Okay, so as we saw, we have to provide the library search path. Okay, using the set attribute, we have to mention the library name. Then so we are using the Verilog, so I using -v 2001, the name of the file. I am setting this as a top level, so we have to elaborate first, then read the constant file using the flatten group. Then synthesis is low effort, so I just write the get netlist using write command. This is just a combination of this top level name along with the rc.vh. Okay, you can write SDC and then some report generation like get reports, power reports, then area reports, timing reports. Okay, under this path and under the name. So for the running this, we can use the rc-f name of the TCL file, like that. Okay, or you can use the rc GUI. Just hit enter, it will take some time. Okay, under this file you can go source script in this way, or you can write the things in this console as well, like source, like that. So it will just try to optimize like that. Okay, these are the generated schematic using the gates from the specified library. Again, we can have the reports from this GUI as well. Endpoint histogram, number of counts, stack limit, like that. These are the things you can have. This is the worst case scenario for the timing constant. Okay, we need to check the log files, so I just close this. We need to check the log files or reports generated from this. Okay, under the 45 we have to check what we have. Get netlist, so this is a generated get netlist. As we saw, everything is made by the gates and the flip-flops. Okay, these are the component from the. You can also check the area report as well. In this report there are 17 cells are used and the cell area is almost 67. Then we can also, these are the much detail regarding how many gates we are using and what are the instances numbers. Take details of all the reports. One important report like timing report, we can also, these are the timing reports. We have kept the 100 mega, for that it is showing that this slag is positive, so there is no need to worry about. So in this way we have to go through each and every reports and check the constant or meet or not. According to the requirements, we have altered the code or constant files. Please subscribe my channel and support me.